Today's topic, SC Framework, the Assembly Notebook. For this tutorial, we will use the Zebrafish Heart Atlas dataset from Tarasco et al. This scRNA-seq dataset contains over 34,000 heart cells across 10 development stages, ranging from 25 hours to 60 days post-fertilization. We will start by assembling an data object from a raw H5AD file, and in the following videos we'll make our way through the journey of quality control, cell and gene filtering, normalizing, batch correction, dimension reduction, and clustering, followed by additional downstream analysis tutorials. Each analysis should start with the assembly notebook. This notebook is used to load or create an data object, which is prepared for subsequent analysis notebooks and saved as an .h5ad file. Depending on available data files, multiple options exist to create the data object. The input format choice depends on your data source and pre-processing pipeline. The notebook provides 4 possible input options. Option 1. Loading data from an already existing H5AD file. Option 2. Providing a path to a star-solo quant output folder. This option is intended to assemble an data object from the standard star-solo output folder, which is done by scanning through the folder structure and using the matrix.mtx, barcodes.tsv, and genes.tsv to create an data object per sample. Each sample files are then combined into one object. Option 3. Providing a path to a directory containing MTX and TSV files. If you do not have star-solo output, but you also have MTX and TSV files, use this option to load your data. This option also requires you to have 1 MTX and 2 TSV files per sample, of which 1 TSV file contains the cell and 1 the gene metadata. And lastly, option 4, loading an R object. If you have data that was generated via the R language, you can simply give the path to the RDS or ROBJ file, which will then be converted to a Python and data object. The first step for this is to run the setup cell. In this cell, all required packages and information from the configuration file is loaded. Next, we are going to load the scRNA data. The Danio Heart Atlas is provided in .h5ad format. Thus, we will choose option 1. To choose option 1, we have to adjust the path given for the variable, path_h5ad. After filling out the blue input cell, run this, and all following cells up until section 4. Any additional cells provided for the other options are automatically skipped. The data is now loaded as an data object. It contains cell metadata in the .obs attribute and gene metadata in the .var attribute. The notebook displays a selection of rows for you to get an overview of the data. In section 4 of this notebook, we can rename or remove observation and variable columns if needed. To remove data from the metadata tables, simply add the column name to the drop_obs or drop_var lists. To rename a column, insert an entry into the respective dictionary of which the key is the current and the value is the new column name. The notebook also provides additional options to adjust existing or new layers of the data object. Run the input cell and the following cell to apply all customizations to the data object. The last section of the notebook gives you a final overview over the assembled data object and saves the object into an H5AD file. With this finished, we have completed the first notebook of the RNA analysis. If you plan to use this or one of our other notebooks, please check out our Docker image, which comes as a full functional environment for the SC framework to be used within a web browser. The next video will focus on the quality control of the data. If you need further assistance or want more information, be sure to check out our documentation or visit our GitHub repository. Thanks for watching.